Welcome to Chapter 1, Section 4, Properties of Exponents. Our essential question is, how can you write the general rules involving the properties of exponents? What you're going to learn is how to use the zero and negative exponents, how to use the properties of exponents, and how to solve real-life problems involving exponents. All right, so example 1, we're going to be using zero and negative exponents. Okay, so we're going to go ahead and start with the zero power property. So we have 6.7, it's a decimal, raised to the power of 0. And now this is the easiest one to remember. Anything to the power of 0 is equal to 1. Okay, anything to the power of 0 is equal to 1. That's it. That's the rule. Okay, we follow that to the T. Doesn't matter if it's a decimal, doesn't matter if it's negative, doesn't matter if it's a fraction, doesn't matter if it's a very, very large number. Anything raised to the power of 0 is equal to 1. Second rule, we have negative exponents. All right, so a negative exponent will reciprocate our number inside the fraction, inside the parentheses. So what that means is it basically flips whatever number is inside the parentheses. So what that means, I'm going to go ahead and put a 1 over this, because every whole number I could divide by 1 and make it a fraction. Okay, so what this negative exponent does, so here I'm going to go over this way. So because this is a negative, the exponent is negative, I'm going to have to switch the top and the bottom of this number inside the parentheses. So I'm going to put the 1 on top and the 2 on the bottom. All right, I'm not quite done there. Now the exponent, instead of being a negative 4, now becomes a positive. Okay, so a negative exponent causes this reciprocal to happen. It flips the fraction over. Next, I'm going to take this value here and I'm going to apply it. So like a regular positive exponent, this is going to be equal to 1 over 2 times 1 over negative 2 times 1 over negative 2 times 1 over negative 2. So it's 4 times negative 2, or 1 over negative 2. So then that becomes 1 times 1 times 1 times 1, which is 1, and then 2 times 2 times 2 times 2, which is 2, 4, 8, 16. And it's negative times a negative, which becomes a positive, times a negative is a negative, times a negative is a positive. So we have positive 1 over 16. Oops. And there we go. All right, next up, we're going to apply this to an expression. We're going to apply the zero exponent property followed by the negative exponent property. And we're going to write our answer in only positive exponents. So I'm going to start here. I have 4x to the power of 0 over y to the power of negative 3. Okay, so here it is important to note that this 0 only affects the x, sorry. The 0 exponent only affects the x. It does not affect the 4 because it is not directly attached, okay? Because remember, there's an invisible multiplication going on here. That multiplication sign actually separates the 4 from the x. So the 0 does not affect the 4. So when I am simplifying this expression, okay, I'm going to go over here to simplify. The 4 stays the same. It doesn't have an exponent, so I'm going to leave it as it is. Now I'm going to do this right here. X to the power of 0. X to the power of 0, anything like we said in the first example, anything to the power of 0 is always 1, even letters. Okay, so this is 4 times 1 now, up at the top. And then we have this, y to the power of -3. So remember, in our properties of exponents, anything that's to the power of a negative number is basically going to switch positions. So I'm going to switch this up to the top. So it's on the bottom, so I'm going to go ahead and switch it and put it on the top. So I'm going to do y over y to the power of +3. So now that I've switched it, the negative sign goes away and it becomes a positive. So it looks like I don't have anything left on the bottom. So the bottom actually doesn't exist anymore. And now I just have to simplify everything. So the stuff that I can multiply, 4 times 1, and then the stuff that is left over. So then this is my fully simplified expression using only positive exponents. So my exponent here is positive, which is what we wanted, and everything is fully simplified. There's nothing else I can multiply. I can't multiply 4 and y because I don't know what y is. And this is my final result. So next up, we're going to use some further properties of exponents. And it says we're going to simplify each expression again and write each as a positive exponent as well. So I'm going to go ahead and start by first dividing the sections. So we have 3 problems. All right, so the first thing we're going to do here is we're going to do 3 to the power of 2 times 3 to the power of 6. Okay, when the bases are the same, when these two bases are the same, we can add our exponents. When the two bases are the same and we're being multiplied, you can add the bases. So this becomes 3 to the power of 2 plus 6. So because our two bases are the same and we're being multiplied, we can add the bases and end up with 3 to the power of 8. Same base and multiply, you add the exponents. Similarly, over here where we have -4 to the power of 2 and -4 to the power of 7, okay, when we have the same base, see, this is a base, is -4 and -4, but you're dividing, remember that fractions mean division, you're going to subtract the exponents, right? So then this is going to become -4 to the power of 2 minus 7, top minus the bottom. That's going to give us -4 to the power of -5. And the explicit rules of our problem say to write our answers using only positive exponents. So remember, we're going to do what we did in the first example. Because this is a negative exponent, I'm going to go ahead and flip everything, put the 4 in the denominator, and it's going to give me 1 over -4 to the power of now +5. Now that I flipped it, I can make the exponent a positive, okay, and this is what I get, 1 over -4 to the power of +5. And our last problem here, we have z to the power of 4 times a -3. Okay, when we have a base raised to the power of one exponent, and then on the outside of a parentheses we have another exponent, we're going to be multiplying those two exponents. So this is going to become z to the power of 4 times -3. which is going to give me z to the power of negative 12. And because this is a negative exponent, I am going to flip, remember, this is 1 over z, or z over 1. I'm going to flip it to get 1 over z, 1 over z to the power of 12. And that is our result right there. That is our final answer there. So we're going to continue. I'm going to go ahead and continue to solve some of these. Okay, these are a little bit more in depth. They have numbers. And we're going to solve everything, simplify everything to its fullest. So I'm going to do, has a combination of numbers and letters. So we have negative 1.5 y to the power of 2. So what I do here is I'm going to attach this 2 to everything inside the parentheses. So it's going to become negative 1.5 to the power of 2 and y to the power of 2. Now I have this calculator attached. If you click at the top, and then all you got to do is 1.5 to the power of 2, and it'll give you the result. So for this first one here is going to be 2.25 y squared, or y to the power of 2. Next up, we have a over negative 10 to the power of 3. Again, because of this is on the outside, I'm going to attach it to everything inside. So this is going to become a to the power of 3 over negative 10 to the power of 3. So then if we simplify it further, we're going to have a to the power of 3 over, and now in our calculator over here, we can say negative 10 to the power of 3 is going to give us negative 1,000. And that's our answer right there. All right, a little bit more complicated now. We have 3d over 2 to the power of 4. So again, because there's an exponent outside of the larger parentheses, we're going to go ahead and distribute the 4 as an exponent to everything. So then that's going to give us 3 to the power of 4 times d to the power of 4 over 2 to the power of 4. If we simplify that, we use our calculator if needed. 3 to the power of 4 is 81. So up at the numerator, I'm going to have 81d to the power of 4. And on the denominator, I'm going to have 2 to the power of 4, which is 16. So then I have 81d to the power of 4 over 16. I'm going to erase this little section here to do the last one. All right, if I have 2x over 3 to the power of negative 5. So this one's the only one that you might want to do a little bit different. So in the other ones, we were distributing the exponent. But because it's a negative exponent, remember that negative flips everything. So I would flip everything first. Put the 3 on the top, 2x on the bottom, and then the 5. Now I can move the 5 inside. Now that everything's flipped, 3 to the 5th power over 2 to the 5th power, x to the 5th power. I'm going to erase some more. This one's a little bit longer. All right, so in the numerator, I'm going to have 3 to the power of 5 which is 243. So I have 243 over 2 to the power of 5, 32. And then the x to the power of 5. And that is our final simplified result for all 4 of these expressions. All right, so in this section you learned about the properties of exponents and what they do and how to simplify them using only positive numbers, exponents. If you have any questions, comments, or concerns, please feel free to post them in the comment section down below, and I will see you all next time.